Today we're going to learn some new terminology. The first thing I want you to highlight on page 123 is this new definition, or this new saying that we're going to be talking about over the next little bit. Rationalizing the denominator. And what it is explained in the words. You know that the denominator is the bottom part of your fraction. And what we want is we want the denominator to be a rational number. So think about your number systems. Rational numbers are like whole numbers, fractions. Irrational numbers are square roots. So sometimes you're going to get something like this, where you have an irrational number in your denominator. That's not allowed. As far as having an answer simplified, we're not allowed to keep a square root on the bottom of our fraction. So in order to get rid of that, we have a process called rationalizing the denominator. Now, the process is very similar to something you've done in the past with fractions. Like if you have to add fractions, you need the same denominator, and sometimes the denominators aren't the same. So for example, if you had 3/5, but the common denominator was 20, does it make sense that you would have to multiply the top and the bottom by 4 to get the bottom to be 20? But when we multiply the top by 4 and the bottom by 4, what's in the square box right there? It's equal to 1. When you multiply by 1, you don't change the value of your answer. You just change what it looks like. So for example, 7 times 1, it's still 7. If I do 7 times 2 over 2, I get 14 over 2. Is that a new number? No, 14 over 2 is still 7. Well, what if I took 7 and multiplied by 3 over 3? I get 21 over 3, which is still 7. So when we multiply by different versions of 1, what we do is we change what our fraction looks like, but we don't change its value. So now I have a square root of the 2 on the bottom. I need to get rid of that square root on the bottom. What could I possibly multiply the square root of 2 by to make sure that it's no longer a square root? Well, if I multiplied by another square root of 2, do you see that the bottom would become root 4? And root 4 nicely simplifies to having a rational number on the bottom. So this is why we call it rationalizing the denominator. Historically, why do we do this? Okay? Because I'm going to tell you, if I ask you what's 1 divided by root 2 to 5 decimal places, you will go to your calculator and you will type 1 divided by root 2 and push enter and get 5 decimal places. And if you do root 2 divided by 2 in your calculator, you could get 5 decimal places as well. We have calculators. Historically, this would have had, if you wanted 5 decimal places before calculators, you would have to develop techniques to do that. The technique of dividing by a square root, this would probably only take you, 6 hours to do by hand to get 5 decimal places. Nice and easy mental math. It's probably not that bad. But this would take people only 45 minutes. So if this took you 6 hours, and this took you 45 minutes to do by hand, can you see why the one is called simpler than the other? It's kind of not useful anymore because they're never asked to do, like if you want, you can look it up on YouTube. How do you calculate square roots by hand? There's ways to do it, but we don't teach you that anymore because we're like, okay, the calculator is much more efficient. Sometimes we have to let technology do math for us. So for that sense, we consider this simplified when we no longer have a square root on the bottom. And in grade 11 pre-calculus, you have to simplify all of your work, so that means you're never allowed to have square roots on the bottom. And there's going to sort of be 2 different situations that we're going to have square roots on the bottom. One situation One situation will look like this. You have a single square root on the bottom. What could you possibly multiply by to get rid of the square root of 7? And whatever you put on the bottom, you have to put on the top. A square root of 7. So what would I get in the end? On the top, I would have 5 square roots of 7. And on the bottom, square root of 7 times square root of 7 is just square root of 49, which is just 7. Still have to times by 3. 7 times 3, 21. That would be considered rationalizing the denominator. The second type that we're going to run into is what happens when you have a binomial on the bottom. Maybe you have 2 square roots, maybe just 1, but it's a binomial. There is a way to get rid of those square roots, and the hint is something that we did yesterday in our first 2 examples. Again, you're going to have to multiply by 1. I'm going to have to fraction that. It's the same on the top and the bottom, and there's a way to completely get rid of the square roots on the bottom using something that we did yesterday in example 1 or example 2. Any ideas? The exact same one? Won't work, because you FOIL it out, you'd still have square roots. Close. You're very close. The opposite. Why would you want to do the opposite?
Because then things cancel themselves out.
You do the opposite. What does this make? What's this called when you multiply those 2 together? Something. Actually, it gets important to know the names of these things. Do you know why it's important to know the names? If you know the name, your brain has a chance of remembering to do it quicker. If we don't, like if you decide not to remember rationalizing the denominator, you're going to find these questions harder than if you decide, I'm going to remember the words rationalizing the denominator. That makes a difference of squares. You are so close. This is a difference of squares, so I'd also have to multiply by root 3 minus root 2. Why is the difference of squares so nice? Because, well, on the top, I'd have to distribute. I'm going to get 5 root 3 minus 5 root 2. And on the bottom, difference of squares says you'll have the first one squared minus the second one squared. And you see when you square square roots, they're going to go away. And we'll end up with just 3 minus 2. And 3 minus 2 is 1. And now we have a rational number on the bottom. So these are the 2 types of places we're going to get square roots on the bottom. So let's go to example 3 and try the first time. So in A, 5 root 7 plus 3 over root 7. Do you see we have a square root on the bottom? We do not have a rational denominator, so we need to rationalize the denominator. What could you possibly multiply by to get rid of the square root of 7? A square root of 7. And if we do the same on the top, we're multiplying by 1. Now on the top of a fraction, it's not written, but it's like assume this is grouped together. There's like invisible brackets there that are not needed mathematically, but they're there. And if you had brackets there and you were multiplying by root 7, does it make sense you would need to distribute? Root 7 times another root 7 is just 5 times 7. Are you okay if I just write 35 all at once? We could do 5 times root 49, and root 49 is 7, and then do 7 times 5. But we can do that all at once. And plus 3 times root 7 will just be 3 root 7. And on the bottom, Root 7 times root 7 is 7. We have rationalized the denominator. We have to make sure we are completely simplified. Okay? Be careful. Because there is invisible brackets here, order of operations say you have to do brackets first and then divide. There is going to be a temptation. Some of you will fall prey to this temptation. You'll see 35 divided by 7, you just want to write 5. It is not allowed because the order of operations say you have to do the top first, and it's adding. You can actually do that if it's multiplying, but not if it's adding or subtracting. The only way you could simplify this with the number on the bottom is if there's something that divides all of them. 7 divides 35, but does 7 divide 3? No. And the root 7 is a whole different thing. It's not part of the, it's like inside a square root, so you can't divide just that inside by 7 either. Whew. Okay. B. Oh, B is going to be interesting. We'll do it right beside it. 6 root 2 minus 4 root 3 over root 18. It looks like an identical question to the one we just did, but this one has something built into it that maybe you can't see yet. But I'm going to tell you, your gut reaction would be to multiply it by, how would you get rid of the square root of 18? Gut reaction would be to multiply by the square root of 18. It's not wrong, but will make your life more difficult. Okay? There is a better square root to multiply by rather than the square root of 18. And you can see the better square root. Some of you probably see it already. You see a smaller one that would work. That's great. But you'll see it if you simplify completely to start with. The square root of 18 can be written in a more simplified form because you can write it as a mixed radical. I can't simplify square root of 2. I can't simplify the square root of 3. But the square root of 18, to know your perfect squares really well, know your times table really well, is 9 times 2, right? And the square root of 9 is 3. So this simplifies to 3 square root of 2. If we write it in lowest form right away, then we can see a smaller square root to multiply by. This will make your mental math easier also. Because I don't know how good your 18 times table is. Okay? So now, again, imagine there's brackets there. We have to distribute this. When we're doing a question like this, try mental math to be one step ahead of what I write down. So when I write down 12 here, you're like, oh, I did that already. Because root 2 times root 2 is 2. 2 times 6 is 12. Right? Always take opportunities in class to push your mental math skills. Because that's how you're going to get them to be better. Right? I started marking your quiz. I was going to finish it this morning, but I left it at home. And on the front page, we are getting lots of little mental math errors that are coming to haunt us. Because every time you make a mental math error, it's like a half a mark. But a half a mark on a 1-mark question, that's 50%. That's harsh. Math is harsh. When you make little mistakes, they add up quickly, and your mark quickly drops from 100% to 75% to 50% very quickly. So we're going to get really good at mental math in grade 11. But it's going to have some growing pains because you guys made a bunch of little mistakes. Times tables, you're gonna get good at it. So in class, you can practice by seeing, did you get this before I write it down? When I multiply that root 2 times negative 4 root 6, negative 4 root 3, I get negative 4 root 6. And on the bottom, did you get 6? Because root 2 times root 2 is 2, and 2 times 3 is 6. Now in this one, again, imaginary brackets, that's there. The only way we can simplify is if there's a number that divides all of them. And can you see that you can divide all of them by 2? So I can write this as 6 minus 2 root 6 all over 3. And this is in simplest form. So simplest form has no square roots on the bottom. Every radical is written as a mixed radical in lowest terms. And if you can simplify by dividing everything by something, that has to be done as well. All right. I'm going to give you some time to try these. So for 13, just do 13I and I right now. When we do the next one, we'll do the I. So you can circle all of 13, but only after example 4 will we